This meeting is being recorded.
In this video, we'll take a look at sample exercise 12 from our chapter 15 chemical equilibrium worksheet. And in this example, we're going to have to use what's called the quadratic formula to solve for our equilibrium concentration. So we'll come back to this when we get there, but let's take a look at what we're given in this problem. Here, we're given our equilibrium reaction up top. We're told that our Kp value at 500K is this 0.497, and we're told that we're given some of this, our reactant, and we're given the initial pressure, and then we're asked to find the equilibrium pressures of all three values here, both our reactant and then the two products. So we know what to do. We know we need to set up an ICE table to get things, keep things organized. So we have our reactant, and then we have all one-to-one stoichiometry, it looks like here. So let's create our ICE table here. So initial change at equilibrium. All right, so let's plug in some values. So we're given that the pressure of our reagent, our reactant that's charged, is 1.66 atmospheres initially. We know that they're all one-to-one, so as this decreases, both of these products will increase by the same amount, and we'll assume that there's zero of the two products at the initial conditions here. Since they're not mentioned, we just assume they're zero. So now we have our equilibrium would be 1.66 minus x. Both of these would just be x. We're given our Kp value, that 0.497. We can set that equal to our equilibrium expression, which would just be x squared over 1.66 minus x here. So we're going to rearrange this equation, and then eventually we're going to use once we get it in a quadratic form, we'll use the quadratic formula to solve for x. So let's take a look here. We're going to multiply these two terms. We're going to get 0.497 times 1.66 minus x equals x squared. We will distribute these values, so we end up with x squared, right? And we multiply this and this times this here. So 0.497 times 1.66, that gives us 0.825, and then minus 0.04, just 497, not 0.497x. Okay. Oh, so this is almost in quadratic form. We need this form, ax squared plus bx plus c equals 0 in order to use the quadratic formula to solve for x. So let's take our x squared. Let's add 0.497x to each side, so plus 0.497x, and then minus 0.0825 minus 0.825 over here. All right, so this will be set equal to 0. Now this is in quadratic form. So the quadratic formula, which you do not need to memorize, you may have a problem or two on your homework that use this, but you can always look it up. We have negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So we're going to plug in values a, b, and c here. So we can do this longhand, or we can use an online calculator. There's a website called calculatorsoup.com that is convenient, but for our purposes, I will write it out a little bit over here for us. So we have our x squared value, or rather our negative b, so we'll plug that in first, so negative 0.497, and then it's going to be plus or minus the square root of b squared. Oh, I forgot to give us our value. So a is 1, b is the value in front of x, 0.497, and then c is negative 0.825. So let's go back here. So we have B squared minus 4 times 1 times negative 0.825 times our C. And then this is all going to be over 2A. So 2 times 1. All right, so after you plug in all these values, you're going to get two answers. If anything is a negative concentration, so we can't have any negative concentrations. But you are also going to get an X value that's positive, and that's going to be 0.693 atmospheres. So this would be our equilibrium pressure for both our two of our products. And then to finalize this, we can plug in 1.66 minus 0.693, and we end up with the concentration of PCl3 equals the concentration of Cl2, and those were equal to that 0.693. And then we also have our concentration of PCl5, that's the 1.66 minus 0.693. That would be about 0.97 atmosphere. So these are our final values over here.